Well, good afternoon. So let us continue. Today we will talk about the standards which the cloud computing generally follows while developing its services, while providing the services. Okay. So in the last class, we have discussed about the storage and how the storage is offered by various uh, organizations. So today we will discuss about the standard, because see any service which is offered via internet, it needs to have some certain standards which are supposed to be followed. When you are learning networking also, data communications and networks, there you will just come across to learn about the various protocols which are generally followed for transferring of data from one machine to another machine. So certain protocols, certain rules and regulations are supposed to be followed. The same sense here also, to establish the cloud computing, you need to have some certain standards. So standards make this World Wide Web go around. They're very important for cloud computing. So they are what make it possible to connect to the cloud and make it possible to develop and deliver the content. Means if you want to develop the content, and if you are supposed to deliver the content from to other machines, here certainly you need to follow some certain standards. So first, means in our discussion, we will discuss about from the application point of view what type of standards we are supposed to follow. Okay, so then after that, we will be discussing about from the client side what type of particular standards we are supposed to follow. Okay, then and from the infrastructure wise, what type of standards we are supposed to follow, we will discuss in these three areas. So one is the application side, one is the client side, and one is the infrastructure side, what type of standards we are supposed to follow. Now from the application point of view, when we discuss that a cloud application is a software architecture that the cloud uses to eliminate the need to install and run it on your computer. Means if a cloud application is a software, it is a software architecture. You know that any cloud application is the one which you are going to access it via internet without actually installing on your system. Means you are not installing on the system, you are just simply using it via internet. Like for example, Google Docs is there. You need not install Google Docs on your system. If you are having any internet connection, simply you can access the Google Docs. Likewise, YouTube is there. Likewise, any other services which are provided on by the cloud, you can simply access them via internet. Only the thing here is you need to have the internet connection, and to uh, access those applications also, there needs to be standard way to connect between the client and the cloud. So there should be a standard way in what way we are going to connect it to the cloud. So if you talk about the communication wise, computers need a common way to speak to one another. Okay, means if you want to communicate, you need to have a common way to speak to one another. Okay, so therefore, to communicate, we generally follow this HTTP. Already you have learned in your web technology is there. The various protocols you have learned, and HTTP is one of the protocol which is used to transfer data between the cloud and your organization. Means here from system to system, you have learned that they are they are used to actually transfer the data from one system to another system. Okay, so likewise here to transfer the data from one system to another system, you are going to use this HTTP mechanism. Okay, so it is a stateless protocol. HTTP is a stateless protocol. The benefit, this is beneficial because the host need to retain the information about the user request, and this forces the web developers to use an alternative method for maintaining the user states. Means what is the stateless protocol in the sense, if you want to have an HTML page, if you want to access some data in using HTTP, you are going to make a request. That request is actually fulfilled, and immediately the session or the connection which is established between the client and the server is dropped. Again, if you are making requesting for a new page, what happens here is again another connection is established, then the transfer of data is done, and again the connection is dropped. That's why it is called as a stateless protocol. But if you want to maintain the states between what happens previously and the previous sessions, you need to have an alternative for maintaining the states here. So the most common way of solving this problem is sending and receiving the cookies. So that's the reason why we will maintain the cookies actually, which are actually used to maintain the track between the pages there. Means what pages we are accessing from one page to another page. Means when you are going back and the previous page will be displayed. So HTTP is a language that cloud and your computers used to communicate. So this is completely a where the two machines are going to communicate with each other. Then they are going to talk with each other. Okay, this is a language which is easily we can understand. Say for example, so the browser initiates by saying get HTTP 1.0 host www.velte.com. The server is going to respond like this: HTTP colon 1.0 200 OK content type text HTML head, and full HTML file will be actually transferred. So the first line of the browser requests the get HTTP 1.0. It tells the browser that it wants to see the site's home page. Means what it is trying to tell here to the server is it just want to see the home page of velte.com. Then after that, the server is going to respond that it is 200 OK, and it is going to send an HTML file. The file which it is going to send is an HTML file. It is going to send the entire HTML file. So for example, see here, if I go to a browser, then if I say some www.velte.com, something, if I'm typing it like this, now I got a web page here. The velte.com web page is displayed. Now if you right click on this and if you go to view source page source, you view page source. So this is what is the HTML content which is actually transferred, which is what is that HTML content which is transferred now. This is what here we are saying, HTML content. So what the browser is going to do, the browser is going to interpret that code and it is going to display the screen here. Got it? So likewise, we have the source code, which is actually so this is the source code of the current Adikavin unannounced email. So when I request that, this source code will be transferred and this source code will be interpreted by the browser and it is going to display. Okay, the first line means that's what I have said here. It is going to display, and whatever the browser received, if it is the images are there, those images are being interpreted and those images will be displayed on the screen. And this is example of HTTP 1.0, but the current browsers are using the advanced versions of HTTP, that is 1.1. The request and response would include bit more information, means some more information is included in this. Okay. The primary difference between the two is that originally web browsers made separate HTTP requests like this for each page, each image, and each other component on the page. Whereas HTTP 1.1, the browser and server can negotiate to leave the connection open and transfer all the page contents without hanging up and opening the new sessions. The meaning of that is if you're using HTTP 1.0, like the previous one, for each transfer means there will be a separate session for each page, each image, each any other component which has been displayed. I mean, separate sessions are used for transferring the images, the components on the page, and any other text, etc. But in 1.1, same session will be used without opening the new sessions, and all the components will be transferred from one place to another place. So HTTP defines 8 methods generally to describe how to defines 8 methods to describe how the desired action is to be performed on the server. So it has 8 methods which are used to which describes how the desired action can be performed on the server. So what this server presents, whether pre-existing data or dynamically generated data, that depends upon the implementation of the server. See, if you remember in the web technologies, we have we discussed about the static web pages and dynamic web pages. In case of static web pages, they are readily available. Means that are already built-in web pages, HTML files, and when you make a request, only that a static web page will be transferred. Whereas in case of dynamic web pages, they are actually created dynamically at the server side, and those are being transferred to the client there. So HTTP is most common way you will connect to your browsers with the cloud. A protocol that is brewing is XMPP. We will talk about XMPP later on. So what are the 8 different commands, or what we can say requests which are made here? So head, ask the response, ask for the response identical to the one that is corresponding to get request, but without using the response body. This is good for retrieving meta information in the response headers, but without transferring the entire. Means the meaning of head and content here is only here the head, only the meta information, means data about the data. Meta information is only transferred in case of head here, head with this command, whereas here the content using get, the content is also transferred. Then you have post method, submits the data to be processed to the servers. So the data is transferred to the server here. The data is included in the body of the request. So what is the request you are making? That data is included in the body of the server. The result of the request might be the creation of the resource or updating the existing resource. The result of the request may be the creation of a resource or updating existing resource. There means you are asking for creating a new resource or updating a existing resource. Put actually uploads a representation of the resource. So put it is uploading the representation of the resource. Delete is going to delete the specified resource. Like trace echoes the request back to the browser so that the client can see which servers are adding and changing the request. Likewise, you have the other options, request HTTP methods that the server supports for the given URL. Okay, this is used to check the functionality of the web browser. Then you have converts the request into transparent TCP/IP tunnel. So it is going to use the TCP/IP protocol here. It is usually used to facilitate the SSL, the secure socket layer encrypted communication through unencrypted HTTP proxies, because HTTP is an unencrypted protocol here, an encrypted proxy through which the connect is going to use the SSL encrypted communication. Then you have the XMPP, the Extensible Messaging and Presence Protocol. XMPP is an extensible messaging and presence protocol. Is being talked about the next big thing in the cloud computing. The problem is that the cloud services, including SOAP and the other HTTP-based protocols, okay, simple object access protocol and the other HTTP protocols are all one-way information exchange. So if you're using HTTP, it is a one-way information exchange here. So HTTP requires multiple polling events to update the status of a browser. Means because it wants multiple polling events to update the web browser here. This means that cloud does not operate in real time and might have difficulties in clearing a firewall. So in real time, it is difficult for the cloud to access, to work out, to clear the firewalls. XMPP actually, this extensible messaging and presence protocol allows two-way communication and eliminates polling. So we have a two-way communication, and it's going to eliminate the polling there. And XMPP, also known as Jabber, is a protocol that Google, Apple, AOL, IBM, and LiveJournal have signed on with. But with so many big names already adopting XMPP, why hasn't changed? why hasn't this change been broader, and why aren't the clowns especially using this? So XMPP is not used by uh, uh, all actually, so it has some its own limitations. Okay, with XMPP is the thing here. See, if you think about this, so just discuss it. The thing here is when the problem with the polling, when you want to sync services between two servers, if you want to synchronize the services between the two servers, the common means to have a client ping the host at a regular intervals. Means if you want to update something, if you want to synchronize the events there, you need to ping regularly. Now this is called as an polling. This is generally how to we check our email. So we are going to bring, we are going to see whether any new emails have been arrived or not. So every so often we ping our email server to see whether we got a new messages or not. It's also how the APIs for most of the web services work. The website highly scalability reported in 2008 that Twitter was reporting an average of 200 to 300 connections per second with the spikes that rose to 800 requests per second. Okay, and at one point during the Macworld keynote, the service went down because of so many polls. Means, see, if you are checking the Twitter to check whether new tweets have been come there. So it is just given the analysis in case of 2008, where 200 to 300 connections per second will be established to check whether new messages have been arrived or not at that time. And around 800 it will rose to, at the peak time it arose up to 800 requests here, and sometimes as it is said, the server has come down, and some companies are trying to address the polling problem with existing protocols, but again it is difficult. Okay, so difficult. So Salesforce.com tries to do this by sending notifications back to the web service to avoid polling. That's difficult for the developers, and your firewall will be configured to allow messages back through. See, when we are supposed to receive the notifications, we need to have a permission. So that might be difficult for us. And now why XMPP is not entertained here is it is not HTTP, because HTTP is a very simple protocol here. Okay, so I think we needs to be based on the existing web, and while HTTP serves well, it is not perfect, especially for cloud computing. XMPP was developed for instant messaging of presence and is widely used in these circles. So where XMPP is used for instant messaging, like the instant messengers we are using, like Facebook Messenger, or you can say the WhatsApp. The XMPP may be used there, and allows use to easy two-way communication, eliminating need for polling. So we need not have any polling. So simply it is used for two-way communication, and XML based. It is XML based and easily extensible. It is an XML extensible markup language based XMPP, and it is easy to use for ideal for cloud services, and it is efficient and able to scale to millions of concurrent users on a single service. So using XMPP, what you can do here is you can scale up to the million of concurrent users. Okay, next, if you talk about the security, securing your cloud sessions is especially important, as the security is one of the top reasons here. Because security builds, what type of security protocols which are using, that is also very important in case of cloud computing. Because as we discussed in the earlier chapters, that security is one of the primary concern, the most major concern, if I can say, when the people started using the cloud there. Okay, so that's the reason why we discussed that the data should be kept in an encrypted form. It should be transferred in a more secured way. So here we will talk about the SSL and one means of authentication, the OpenID. Okay, so OpenID. what is this SSL here? Means it is a secured socket layer. Means if you are using a credit card, if you are using some credit card to transfer your money, then it is using properly using the SSL there. It is a standard security technology for establishing an encrypted link between a web server and a browser. So SSL is a standard security technology for establishing a connection. This ensures that the data is passed between the browser and the web server stays private. Means in the most secure way, data is transferred between the browser and your web server in a private way. To create an SSL connection on a web server requires SSL certificate. So if you want to establish a connection, you need to have an SSL certificate. So the cloud provider starts an SSL session. They are prompted to complete number of questions about the identity of their company and their website. The cloud provider's computers then generates two cryptographic keys, public key and private key. So when you're using SSL, so it has to means when you want to cloud provider starts an SSL session, they're prompted to complete a number of questions. So number of questions should be answered by the cloud provider here. Okay, about the identity of their company and the website. Then the cloud provider generates two cryptographic keys here. One is a public key and a private key. The public key does not need to be secret and it is placed on a certificate signing request. So CSR means the public key is placed on the CSR. The file contains your details. Then you submit the CSR. During the SSL certificate application process, the security certification authority will validate your details and issue an SSL certificate. So what is the certificate? Means whatever the certification authority is there, it is going to validate your details and it is going to issue the certificate containing your details allowing you to use the SSL. The cloud provider then match your issued SSL certificate to your private key. So then it is going to match up with your private key, the SSL certificate issued. So your browser will establish the encrypted link between the computer and your cloud provider. Then your browser will establish an encrypted link between you and your cloud provider. So here some steps have been given. The browser checks the website certificate to ensure that the site you are connecting to is a real site and not something else interpreting a spoofing site. Means sometimes there may be some spoofing sites will be there. So you should have an authenticity. You should tell whether you are going to connect to a genuine website or not. So for that you require an SSL certificate. The browser and the website decide what type of encryption to use. Then they will decide what type of encryption they are going to use. Means in what way they are going to send the data. Then they send each other unique codes to use the encryption information to be sent. So then they will choose a unique code which can be used to encrypt the information. The browser and server uses the encryption to start talking. The browser shows the encryption icon and the web pages are passed as secured. So this is a very streamlined process, operates in background. The only difference you are likely to see is that the page takes longer time to load because of this all behind the scenes certificate passing. So sometimes when you load a web page, it may take time. Why it is taking time? The reason here is the same. It is going to have a lot of background process which is carried out. Okay, to authenticate itself, to establish a secured connection, then to transfer the data. On this SSL certificate will be contained your cloud provider's domain name, company name, etc. And it will also contain the expiration date of the certificate and details of the application that is responsible for issuing the certificate. Okay. Then if it fails, sometimes if it is fails, then the secure connection is not established. It is warned that you don't have a secure connection. So you need to have a secure connection for that. Then then you have an OpenID, which we already discussed in a previous chapter. Then OpenID is an open source solution for the problem need of having unique username and password for different companies' websites. This already I have discussed earlier. Means the same username and password can be used by at all the places. So you can use it for Microsoft, Sun, Google, anywhere. So they have adopted for this the single OpenID connection. The single username and password can be used to authenticate yourself. Means you need not have individual uh, different types of IDs need to have. If you go to second chapter, we did have we do have a very mm, clear discussion about this. If you observe, just I will show you once again. You have it in your second chapter. Just I will show you. As for identity, if you observe, the same OpenID connection can be used for Google, IBM, Microsoft, and Yahoo. Means you need not have the individual different connections, different username and passwords. The same OpenID connection can be used with all these organizations. Okay, the same thing can be used. So here it is talking about the same thing. The OpenID Foundation was formed to assist the open source model and access the technology support source of support. So it is actually been established as a form to assist the open source model here. So it is still in adoption phase. At that time, it has been adopted by the big names like AOL, Microsoft, Sun, and all. Then you have the payment card industry data security standard. This also we have discussed the annexuary in the uh, previous chapters, where we discussed in the second chapter itself. We discussed about what type of standards we need to follow when you are having uh, the secured connection. Means if you want to transfer the data from one place to another place, in what way you're going to maintain it securely. So the audit trails, under audit trails you need to have some certain questions which are need to be answered, which means for storing the data. Means for the security standards you need to have some certain things which are supposed to be maintained. So those are provided by this payment card industry data security standard. So that is about the standards things which are from the application point of view. Then we need to have discuss about from the client side what type of standard, means what type of standards are being followed by the from the client side. This I will discuss in the next class. Okay. Any doubts, Mahesh?
No, sir.
Okay then. So we will meet you in the next class. Okay.
Oh, okay, sir. Thank you.
Okay. Thank you.